Hello all, in this video we will solve non-preemptive SJF numerical. SJF stands for shortest job first. So we wish to calculate average waiting time, right, using non-preemptive SJF. Okay. Now in case of non-preemptive SJF, we make use of a priority queue. Okay. Now if you look at the snapshot of the system, you realize that at time 0 two processes arrive, B and E, and imagine that they are entered into the queue in the order B and E. Right? Both processes arrive at the same time, but they are entered into the queue in the order B and E. The order of execution can be illustrated using a Gantt chart. Right? Now at time 0, we need to allocate CPU to one of these two processes, B or E. The algorithm is shortest job first. So when you look at their burst times, the burst time for B is 4 and the burst time for E is 3. The shortest job among B and E is E. So E gets CPU, right? E gets CPU. So E will be removed from the queue and E will be given the CPU. Now since the algorithm is non-preemptive, process E will use CPU until it wants, right? Process E will use CPU until it wants. So it is going to use CPU until time unit 3. Until time unit 3. But what happens is at time unit 1, a new process enters into the system, that is C. But since the algorithm is non-preemptive, C will come quietly and will enter itself into the queue, right, without disturbing the currently running process E. C will be entered into the queue, right? Then at time unit 3, E finishes its execution, and now in the queue we have two processes at time unit 3. One is B and another one is C. Since we have more than one processes, we have to see what algorithm we are using. Shortest job first. If you look at the time quantum or the burst time required for B and the burst time required for C, we realize that C's burst time is smaller than B's burst time. So naturally C will get the CPU. So C will be removed from the queue and C will be given the CPU. Again, since the algorithm is non-preemptive, C will keep on using CPU until it wants. So C will use CPU until time unit 6. And what happens at time unit 4 is a new process enters into the system, that is D, which will come quietly and sit into the queue without disturbing currently running process. Similarly, at time unit 5, another process enters into the queue, which is A, and A will also enter itself into the queue. Now at time unit 6, C finishes its execution, and now we are left with B, D, A. Three processes in the system, and now there are no more arrivals, so life becomes simple. So we have to simply check what algorithm we are using, SJF. So what is the burst time for B? 4. What is the burst time for D? 2. What is the burst time for A? 3. Right. So the shortest burst time is of D. So D will be removed from the queue and D will be given the CPU. D will use it up to time unit 8, 6 to 8, that is 2 time units. Then we are left with B and A. B wants CPU for 4 time units, A wants CPU for 3 time units, so naturally CPU will be given to A. A will use it for next 3 time units, 8 to 11, that is 3 time units, and finally we will get CPU for B, and B wants to use it for 4 time units, so that is up to 15. Okay, so that would be the order of execution using Gantt chart. Now let us calculate the waiting time. Let us calculate the waiting time for all the 5 processes. So what is the wait time for A? A came at time unit 5 and got CPU at time unit 8 and then it finished. So 5 to 8 it was waiting, so it's 3. 5 to 8, the difference is 3. B came at time unit 0 and got CPU at time unit 11. So from 0 to 11 it was waiting, so that wait time is 11. C came at time unit 1 and got CPU at time unit 3 and then finished. So 1 to 3 it was waiting, so that's 2. Right? D came at time unit 4 and got CPU at time unit 6. So 4 to 6 it was waiting, so that's 2. And finally process E came at time unit 0 and got CPU also at time unit 0. So there was no wait for process E. E immediately got the CPU and then finished its execution. So its wait time is 0. So if you add up all these values, it is 18. That's the total wait time. If you want to calculate average wait time, we will divide it by the number of processes. Number of processes are 5. So this would be 3.6. So the average waiting time, right, using non-preemptive SJF will be 3.6. Okay, I hope you have understood this. Thank you.